You're listening to Masonry Principles, your guide to building better buildings, with hosts Amanda Bedian and Phil Leden.
Welcome to Masonry Principles. Today we will be focusing on site safety and specifically bracing masonry walls during construction. And on today's episode, we have two of, I'd say, the experts in wall bracing with us. We have Todd Dailey, who's the owner of Dailey Engineering in Michigan. And we have Kyle Lochonic, who is a project manager with Davenport Masonry and Restoration, located near Lansing, Michigan as well. So welcome, Todd and Kyle. And today specifically, I wanted to focus on some of the advantages of internal wall bracing versus external wall bracing. And so I guess, Todd, we'll start with you. You've been involved in doing a lot of wall bracing designs for our contractors in Michigan. Can you give our listeners a little perspective on what you do, kind of what projects you've been involved with, and for how long?
Sure. But before I dive into that, I would just like to say that I am the first of my family to participate in a podcast. And here we are recording on St. Patrick's Day, so I could not be happier. All right, wall bracing. As many individuals know, internal wall bracing got its start in Michigan. And Davenport Masonry was the key in that development. As I understand the account, the owner of Davenport recognized as walls started getting more and more reinforcement in them, starting in the 80s, that they weren't losing walls during construction like they had before with less reinforcement. Well, that led to eventually research on early age strength development of masonry, both reinforced and unreinforced, and it has led to this concept of internal bracing, where we're actually able to use the strength of the masonry to resist wind loads. There's so many advantages of it. I don't want to just keep going headlong into all of the advantages, but I'll say this, that where internal bracing is appropriate, I believe it to be the safest type of wall bracing. It has taken off. Michigan still is where I do most of my work. It is I would say, the dominant form of wall bracing in Michigan. But I've worked on projects now in about 33 states, and we're approaching 2,000 wall bracing projects.
Oh, yeah, that's outstanding. So I guess, I mean, for our listeners, so there's two types of bracing walls during construction, because essentially as we build our masonry walls up until we get a tie-in at the roof, we're virtually unsupported and cantilevered from our base. And so historically, our walls have been more susceptible to collapse during construction from wind loads until we get that roof attachment or the floor attachment. So we can either brace our walls externally. So I think many people are familiar with pipe braces or other means of bracing walls. Precast tilt-up panels are a good example that utilize external braces until they get that roof connection. But since we started introducing reinforcement into masonry, like Todd said, in the 80s and especially in the 90s here in Michigan, a lot of cases we don't need that external bracing, and so we can rely on the reinforcement to resist those wind loads. So, Kyle, from a contractor's perspective, I guess some of the advantages that I see are, site access. We don't have those braces everywhere, but can you elaborate a little bit on some of the advantages from a contractor's perspective?
Sure, like you said, Phil, the lack of having wall braces in the way is very significant for the whole construction site, not just for us, but for other trades. Knowing that the walls are internally braced and are not going to be susceptible to failure, providing that level of safety, which is what this is all about, right? A level of safety for the workers on the job site. It makes it much more, I guess I'll use the word, easier for multiple trades to work in locations. They don't have to abandon an area where we're working while we're working. They can work next to the wall on the other side doing what they're doing.
And in terms of those other trades, because we do have a restricted zone, so what type of training or what kind of awareness do those other trades need, I guess, to be aware of to be able to work within that restricted zone of that wall?
To work within that area, you have to be trained. We provide training. If you want to if we can go back for a minute historically, Todd stole some of my thunder like he always does. Michigan was the first state to have a wall bracing standard. It was released in 1989 after 13 years of development. At the time, as you mentioned, that's when walls were transitioning to taller reinforced walls, and our standard by the time it came out was probably a little bit behind the times. We used plank bracing most effectively for walls up to 16 foot. That was about it. It was designed by the University of Michigan. Recognizing what was going on, as Todd said, we started noticing that as we were doing more internally reinforced walls, we were developing strengths, and they weren't blowing over as much. And the standard that Michigan had allowed for an engineered form of wall bracing other than the plank bracing. So we went right after it, started doing some strength testing on grouted and reinforced masonry, and we determined that within 24 hours we had 50% of the strength of the grout, which enabled us to establish that over a period of time, those walls gained strength. And so that led to the first national wall bracing standard, which was developed by the Mason Contractors of America, the standard practice for bracing masonry walls under construction. And it was released in 99. I think they had 2 years in committee. And that established an initial period, which is the first 24 hours after the wall is built, when the mortar and the grout still really haven't developed any strength, and you're relying just on the mass of the wall to resist the wind loads. And the intermediate period after 24 hours until, as you mentioned, that wall has its final connection, when the wall has about 50% of its strength and the strength is growing. So using that, we were able to determine, what these walls can withstand, what kind of walls can withstand what, and establish that level of safety where we could rehab this restricted zone where people could work as long as the wind speeds were being monitored. We provided, and then we went into my OSHA committee. We formed a committee. It took us about, I'm going to say 10, 12 years, a little bit longer. We had a very bad construction failure in August of 1999 when a wall blew over in Flushing, Michigan and killed 4 construction workers. So Dan and I immediately started lobbying my OSHA to open the standard. It took us quite a while. We finally got it reopened in about 2008, and we republished it in 2010, adding all these things that we have in the standard practice for wall bracing, those restricted zones, the wind speeds, and with that, we established a level of training statewide where we do a wall bracing training standard on the MyOSHA standard, how to work in those restricted zones, what they need to do. We traveled the state because whenever you release a new standard, you have to train statewide, and did those trainings. We provided some online through Washtenaw Community College, and to this day, you can get those trainings from many places. I do them. My safety guy does them. I think you guys do some. Todd's probably doing them still.
Yeah, we do some wall bracing training, and MyOSHA's been incredibly supportive. We actually have an agreement between the Masonry Institute of Michigan and our Michigan OSHA, not only to train their personnel, but just so that way they can be active and involved in kind of what we're developing as we move forward. So I guess, I mean, that's really good history. I mean, Todd, from working in other states, because I know if you go to federal OSHA, there's not a whole lot of information about bracing walls other than if you exceed 8 foot, they need to be braced. But it doesn't tell you kind of how or what you're bracing it for or anything like that. Michigan's done a really great job with that. How have other states done, Todd? I mean, have you seen other OSHA jurisdictions doing something similar to Michigan?
No. Michigan is the only state that has adopted the standard practice into a specific safety standard. And I'm going to kind of do a contrast between the standard practice and the federal OSHA standard. The OSHA standard could be summed up in a couple of sentences, perhaps just one. Brace the walls so they don't tip over. And while that may sound good on the surface, yeah, that's what we want. Well, there's some issues with it. For one, it's unrealistic because you think about the kind of wind forces that can occur in life. Hurricanes, tornadoes, they can come through and level permanent buildings. But yet, on your job site, if that same wind event hits and your walls blow over, which they will under those kind of forces, technically, you failed to meet the OSHA safety standard. So it's unrealistic. Another problem with it is it's too vague. There's no mention of wind speeds to be designed for. In contrast, the standard practice, its focus shifts to life safety. And it openly states that, hey, we're going to lose some walls during construction under severe wind events, but we're going to keep people safe. So it specifies very specific wind speeds to use for the design of whatever temporary bracing system you're going to use. Along with that, and this is key, is wind speeds are to be monitored at the job site. And when wind speeds get close to those design numbers, you get people away from the walls to a place of safety. Big shift in focus, and I think it's right on track with what it should be.
We've also added to that a signage area of the wall, which is the height of the wall plus 4 feet. It's called, the collapse area, so that people who are within that area must be trained, must be monitoring the wind speed, so they know where they have to go when it happens.
If Michigan's the only one following the standard, what are other states doing?
Well, I'll maybe clarify just a little bit. Michigan is the only state that has legally adopted the standard practice as part of its state-specific safety standard. That doesn't mean that other mason contractors or entities don't use the standard practice. They're just not often contractually obligated, but it is gaining traction throughout the country.
Yeah, it was developed by the Mason Contractors Association of America, which has a large membership, and they have spread the word. Todd travels and spread the word. Phil, Todd, and myself are all members of the TMS construction code committees, and so we meet with a lot of people nationally and have done a good job. We actually have a wall bracing committee that meets at those meetings to help get the word out on how to be safe during masonry construction. Bottom line is we all want our guys to go home every night just the way they came to work.
Absolutely. What are some things or some questions that you've gotten that you would like to share, like just some public knowledge that could help them in their next time they're planning wall bracing?
Go ahead, Todd. You do the presentations all the time.
Well, of course, I have a biased view, but I would encourage mason contractors with wall heights 30 foot and above. I really believe it's in their best interest to hire an engineer to assist with the wall bracing plan. So that would be one thing I would promote. The other is, again, just getting the knowledge out there of what internal bracing is, how it works, and why it can be, as I say, the safest form of wall bracing that we have available to us. Could I touch on economy for just a minute, Phil?
Yeah, absolutely.
So, with the standard practice, we've already talked about how a great opportunity to improve job site safety. But here we can get not only better job site safety, but we can lower the wall costs. And I say that because, again, internal bracing is usually using the early age strength development of the masonry, oftentimes the reinforced behavior. In my estimation here, about 80% of walls, masonry walls that are going to be built, already have enough reinforcement in them per the permanent design that they're going to qualify as internally braced. You can kind of view it as getting the bracing for free.
Yeah, and I mean, especially I think in Michigan, we're kind of worst case scenario because we're not in a bad seismic area. You start looking around the country, out west or even down south, New Madrid area, and I mean they add a lot more reinforcement to their walls prescriptively just because of their higher seismic risk. And so in those cases, I would think that nearly all of their walls could be considered internally braced just as a function of that prescriptive reinforcement.
Yes.
But in Michigan, I mean, well, a lot of times we don't see rebar spacings much beyond 48 inches, which in many cases can get us a reasonable wall height internally braced. And I mean, through the Institute, I've been really lobbying for engineers to increase our reinforcement spacing as a matter of economy for projects, but I still think we can get to a reasonable level of safety with moderate wall heights. I do want to touch real quick on lapse places, just because that's been a huge topic at TMS, and just kind of as an example, for our listeners about just kind of code development. The standard practice does require a 48 bar diameter lap splice, which if you use our current masonry provisions, you can get away with less of a lap splice using the masonry code. And some engineers do take advantage of that. But with the standard practice, we have been really trying, and Todd's been trying for years. I mean, Todd, do you know how long you've been trying to do that?
Get a foundation dowel requirement.
Yes.
6 years, Todd, nonstop.
Yeah, 6 years, and unfortunately, I think it's going to fail in the current code cycle, which is the 2022 edition. So I don't think the earliest that we're going to see it is probably going to be a masonry code that approaches the year 2030, if then. That is an obstacle. I don't quite know how to win that battle yet. So I'm personally focusing my efforts on the contractor side. A little thing here is, as the code is written, the splice lengths that are presented in design drawings and specs are minimum lap splices that contractors are obligated to follow. They are not maximums. So if there is a job where the lap splices are below what we currently have research for, the 48 bar diameter, I encourage the contractors to voluntarily use a little bit longer lap splice to get that internal bracing. And usually, from a cost standpoint, it's spending pennies to save hundreds. You talk about eliminating all of the pipe brace setups.
Absolutely, Todd. We do that all the time, and like Phil said, he is pushing engineers to spread reinforcement out because they have gotten quite carried away with it of late. We see that very occasionally, but if Phil is more successful, there may be times where it gets out beyond the wall bracing requirements, and we are usually pretty successful at then having them just bring it back in a little bit so that we can make sure those walls are safe during construction. On the base of wall dowels, Todd, you almost made it this time. And like I told you at the beginning of the code cycle, if we stay after it, we'll get there. It just is going to be a long struggle. I think we made enough connections with enough people that when they've had a little bit of time, we'll get around the corner.
But I think that's just a good example. I mean, it's going to take 12 years, to potentially. I mean, if you just think about that just in terms of time, right? I mean, it's dedication and time. And so, I mean, you and Todd have been really after it, especially. But I mean, that's just a long time. And I think people that aren't involved in codes directly don't really think about code development and just the length of time it does take to get things in there.
Yeah, it's not simple. I mean, if you look at the original wall bracing standard in Michigan, it took 13 years to develop. When we knew that it needed to be changed, it took us almost 12 years to get it reopened. We went to public hearings twice a year for 12 years. Dan Zachmeister, your predecessor, and myself. So it's a long battle. You got to play the long game. That's not unusual, and I don't think any other industry. Look at how long it took us to get ladder wire changed to 16 inches on center.
Right. And I think the other thing I wanted to touch on too, from a contractor's perspective, so Kyle, hopefully you can shed some light on this, but I think internal bracing really lends itself nicely to low lift grouting, so limiting our grout pours to our grout lifts, sorry, rather to 5'4" increments instead of high lift grouting, because then we're kind of building our strength as we work our way up the wall. Is that what you kind of see in the industry, I guess, Kyle, and also Todd? I mean, do you see a lot of contractors using low lift grouting because of the advantages with internal bracing?
Yeah, that's exactly what you see. If you're going to go too high lift grouting, I mean, you're kind of limited to 8-foot sections by the wall bracing standard, because at 8 feet you have to be, once again, you have a wall that has to be braced, right?
Right.
if you don't have, if it's not grouted and reinforced, you're going along. So yeah, we see a lot of, it does lend itself to low lift grouting.
Phil, I'll add just a little nuance there. Yeah, low lift grouting is the dominant form I see. Well over 90% of projects utilize that method. It is possible to be in compliance from a bracing standpoint with the standard practice and go a little bit higher than the typical low lift grouting. For example, for 12-inch CMU, we can go up to a height of 14 foot roughly. And in the unreinforced condition, that 14-foot, 12-inch wall still can take a 40-mile-an-hour wind. So you can apply that if there was interest or an advantage to doing a modified high lift. Keep your grout lifts to no more than 14 foot, and you'll be in compliance with a strong wall all the way till you top it off.
And that would be 8 foot with 8-inch block, right, Todd?
8, maybe 10 foot, depending on what type of mortar you're using.
That's just a function of the weight of the wall counteracting the wind load plus your flexural tension in your mortar. Is that correct?
It's the flexural tension in the mortar, exactly. You know, we've talked about how we get 50% of our wall strength after 24 hours. That applies to both reinforced behavior, the grout setting up. It also applies to the mortar in an unreinforced wall with the flexural tension. 50% strength in 24 hours.
So you see us using a lot more type S mortar cement nowadays on block walls just for that reason.
Right. Yeah. I mean, I think historically, we've even advocated sometimes for type N cement for interior partition type walls, just for cleaning, especially with burnished units
Sure.
or things like that. But type S definitely gets us a lot more strength in terms of unreinforced, especially. So, yeah, that's a good place to be.
You just have to look at your conditions and what you're doing. One thing I'd like to add is, we almost got it done during this last code cycle, but things kind of just went asunder at the end. But we have an opportunity to do some testing on dowels. We have a test model designed, and at some point we'd like to get that funded. I think we will find that there's quite a bit more strength there than we believe. That test model will help with reinforcing laps throughout the wall once we see how they're actually tested. Our previous testing was maybe not to the level that we have the sophistication to do in these current times.
Right. So I think our original lap splicing um, testing was just in direct tension. So we basically put a bar and grout in a block and then put a piston on it and ripped it out of the wall.
Yeah, that's exactly what we did.
We really need to test in flexural tension. And I think we will see that we have more strength, like you said, Kyle, and maybe that means our lap splices go back down. But I mean, like Todd said, I mean, what is the cost difference? I mean, are we saving pennies versus, dollars? But I mean, anything is an advantage. I mean, and so lower lap splices would definitely be another advantage to the system.
Well, sure. And plus, we've worked with Mark McGinley to design this testing. He's a avid member of the TMS. Once the engineers see some of the results, that may actually help with Todd's commitment to get them to put fixed dowels in walls for safety during construction, because they might find out there's a lot more strength there than they're anticipating. They might want to take advantage of it then.
Yes, I think that might be a collaborative thing that might help move that forward. Historically, where did the 48 bar diameters come up from? At the time that the standard practice was under development, 48 bar diameter lap splices were the norm.
Right, that was the standard at the time.
There was no thought to test something less than that.
Yeah, they actually went at that time. They increased for a short period of time.
Yeah, I believe that equation is actually still in the International Building Code or most state adopted building codes. It's like 0.002 times your flexural or times your yield strength times your bar diameter. And based on our older yield strengths, it used to work out to 48 bar diameters. But then when our yield stresses increased, I think it went up to 64 bar diameters, or possibly 72 for a time. And so, yeah, I mean, just different things that just didn't kind of keep up with our advancements in the code.
Sure, it just shows that codes are living, breathing documents as people learn more about the properties of the materials that we're working with.
Phil, can we talk about shafts before we're done?
Yeah, absolutely.
Shafts are, many people on construction sites come to recognize, shafts like elevator shafts, stair shafts, they are inherently strong. Winds hit job sites, and that's the one thing you don't have to worry about typically. And shafts are so strong against wind because they have the corners that brace the straight runs of wall. That is, by definition, internal bracing. If you wanted to scrape beneath the surface, it's horizontal spanning action, unreinforced usually, of the walls over to the corners, where it then has shear walls to support it. So it is pretty easy for masonry shafts to be able to be built to 80 foot or more without any other form of temporary bracing.
And I can support that. We've built a lot of shafts. We're seeing a lot more masonry shafts on buildings. And we actually had a pretty good field test a couple of weeks ago because we had just completed a couple 70-foot shafts when we had those 60 to 70 mile per hour winds.
And you didn't see any issues.
No issues at all. I didn't even lose sleep. In the old days, those kind of winds, I would be driving around to my job sites the next day to figure out how much insurance claims I had to come up with.
An important thing, if we're going to look at shafts in that way, where it's the horizontal, unreinforced spans, we can't have control joints in them. Then we lose that ability to behave in that way.
That's correct.
And I think how they typically build shafts, and correct me if I'm wrong, Kyle, but sometimes, I mean, depending on geometry or orientation, the hydromobile could actually be in the shaft itself. And so you're building all four walls kind of concurrently. So, I mean, there's not really a lot of opportunity to brace those walls just because of where your hydromobile or scaffolding is located.
Sure. Sometimes it's on the inside. A lot of times it's all the way around the outside. But in either case, it would be in the way.
And so we can't really brace those walls. So yeah, I think that's an area of focus that I've really been pushing on CMA on as well, is control joints in shafts, because unless we hit a specific length, I mean, I don't advocate for them at all. I think we get a lot better performance that way.
Yeah, I agree. We've never used them and we've never seen a problem.
So with that, is there any closing thoughts either you want to add?
Phil, I have a plug if I can make.
Absolutely.
At least for this year, MCAA is offering wall bracing webinars on a quarterly basis. So very convenient. People can receive this instruction right at their offices.
Like at dailyengineeringinc.com, you've got some customer resources as well. Are there any other guides or aids that you would like to point anybody to?
Thank you for plugging my website. That information that I published there is free to whoever wants to look at it and use it. IMI has published a brochure on internal wall bracing as well that some might find useful.
Great. Thank you so much. Is there anything else you want to cover before we sign off?
To wrap it all up, I mean, we do have our standard practice. Federal OSHA has some information regarding external bracing, albeit not much. And if you're in another state listening, I would definitely encourage you to read My OSHA Part 2, where I think our My OSHA, along with Kyle and Todd and Dan Zeckmeister, did a really good job at elaborating on our OSHA requirements. Because I think, anyone in this industry understands, safety is the most important thing. Like Kyle said, the most important thing is everyone getting home at the end of the day. And so I wanted to thank you both for being on today's episode. Thank you to all of our listeners, and be sure to check out our other episodes at masonryprinciples.com or on Apple Podcasts, Google Podcast, or Spotify.
Thank you for listening to this episode of Masonry Principles. To continue the conversation, be sure to reach out to us by visiting masonryprinciples.com.